Everybody, it's Mrs. Dinkelman again. This is just kind of the wrap up of all the integral or integration techniques that we learned in Unit 7 and how we just decide what to do. So I just have this flow chart. It might be helpful, it might not to you. I'm just going to kind of go through a little bit and then you're just going to get started on the assignment because it's just a matter of trying to make a decision and see what happens. Please don't be afraid to make a decision and then get into some complication and just stop and try something else, because that's what we do as mathematicians is we try something. If it doesn't work, we have another strategy we can use. Okay, so I would always look for if there's a way to simplify first. This also puts U substitution in there. Although what I would say is I'm always trying to make a decision between U substitution and parts. So the difference again to me between U substitution and parts is with U sub you're going to see a function and its derivative sitting there together. Whereas with parts, they're going to be two things multiplied together that seem to not really have any relationship, like not a derivative relationship. Okay, so there's your by parts and that Lipit. So that just is again how we decide how to use U. And there's the setup, although they have the V and dV, where I stole this from a little bit different from where we have it. Some strategies again, maybe this is a different way to think about your trig integrals. Remember, technically on the AP exam, you won't have to do this, although you'll notice in the assignment, you'll see that happen. And then there are partial fractions. So to me, when we have partial fractions, we always have a rational function. So it's a matter of deciding, again, between U substitution and partial fractions. For me, the decision is, does the derivative of the bottom match the top? Again, does the derivative of the denominator match the numerator? If that's the case, it's a U sub problem. So let me just kind of scroll through here and just make a couple comments on some of those. So like number 1 here, I would simplify and I would kind of stretch out that numerator a little bit and just see if there's some simplification we can do. Number 11, what I'm noticing, a lot of cosines in here, but the derivative of cosine is negative sign, so this seems like a U sub. Number 12, so 12 and 13 look awfully similar to me. The difference between the two of them is look inside the root. The derivative inside the root is negative 2x, which is close to what's happening in number 12. So that means 12 is U sub, probably means 13 is going to be trig sub. And let's look at 3. So this is another rational one. The derivative of the inside of the parentheses is really just a 1, which is not what's going on in the top. So that tells me this is probably a partial fractions one. Okay, number 5, just a quick reminder about what the derivative of tan inverse is. That's 1 over 1 plus x squared, so this looks like a U sub to me. And then let's see, 6 is a really good example of parts because we have a cosecant cotangent and an x also, and those are not very related. So that looks to me like it's going to be integration by parts. That's the ultraviolet voodoo. And a quick reminder as I'm looking at 17 and 18, remember that if the degree of the numerator and denominator are the same, or the numerator is higher, that we have to do long division. So it looks like we might have to do something with long division on 17 and 18. Okay, go ahead and get started.